Dear students, how to solve numericals in NCERT based questions. So students, to know some answer of NCERT question, we focus some of the formula to solve this. You know, if resistances are connected in this way, suppose R1, R2, R3, these are the three resistors connected in series. How to know these are in series connection? There is a single path in this way or in this way, because it is a single path of current flow. If there is a single path of current flow, then these are in series combination. So what happens? For these three resistors, you can place one resistor, that is R, and this R is known as equivalent resistance or effective resistance or net resistance of R1, R2 and R3. You may consider more number of resistors, but here only three resistors I have taken. So what is the value of R? R is equal to R1 plus R2 plus R3. So instead of three resistances, you can use only one resistor. So what important point you have to remember? Current is same in all. Current I, it is current I, it is current I. I mean same current will flow in all resistances, and the voltage drop here is V1, that is I into R1. So one writes V1 is equal to I into R1, voltage drop across this. Similarly V2, similarly V3, V2 is equal to I into R2, V3 is equal to I into R3, and total voltage given to this circuit V is equal to V1 plus V2 plus V3. So this is the case of series combination. And what happened in this? If one is damaged, then no current will flow, because this will become an open circuit, and you know in open circuit no current flows. Now come to combination of parallel. So if resistors are connected like this, these are the three resistances are connected like this. They are connected in parallel. So what does it mean? If this end are connected together, this end are also connected together, then the resistors are connected in parallel. So what happens in parallel combination? Potential difference V is same. Potential difference across this resistance is V, across this resistance is V, across this resistance is V. So remember, potential difference or voltage drop across each resistor is same. So this is the case of parallel. Suppose I take like this. Same case, these three are also connected in parallel. You see this end, this resistance has this end, this is this end, so all are connected together, here all are connected together. So this is the case of parallel. So in parallel combination, what is equivalent resistance? That is R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this R is the equivalent resistance or effective resistance or net resistance of the circuit. I mean, in place of these three, you can put only one resistance R, whose value is this one. So in parallel combination, the net resistance decreases, whereas in series combination, net resistance increases. But if one resistance is damaged, other resistances are not affected. I mean, to other resistance, current will flow. But in case of series combination, if one is damaged, then no current will flow to other resistances. Here current is different. Current, here current, here current, here current. So current may be different, but voltage must be same. Voltage must be same, but current will be different in parallel combination. We see other formula used. What is other formula? This is your next one is I is equal to E divided by R plus R. This is the case of a cell with internal resistance R. This is the external resistance R. Small r is the internal resistance of the cell of EMF E, electromotive force. Capital R is the external resistance. Keep in mind, every cell has internal resistance. But for calculation point of view, if this is ideal cell, its internal resistance will be 0. But in this case, I consider small r as internal resistance. One says that internal resistance will within the electromotive force, yes. But that is shown here, though it is inside this cell, but it is shown here for clarity. So what is current? Current is EMF by total resistance. You see, both are in series because there is a single path of current flow. Current starts here and moves like this. Since current is in a single path, these two are in series. So net resistance is R plus R. So according to Ohm's law, current is equal to E divided by R plus R. And from this you can get V, I mean IR plus IR is equal to E, and that gives you IR is equal to E minus IR, and this is nothing but V is equal to E minus IR. Of course, what is this V? V is the potential difference across this. V is the potential difference across the external resistance R. V is equal to E minus IR. Here one point you have to remember. Actually this is the case of discharging of the cell. The cell discharges. But if it is charged, you know some cells are charged. So if a cell is charged, I mean for charging, the formula will be V is equal to E plus IR. Why? Because in case of charging, this is the case. Here is a case of charging. Here is the charger. I mean this one charges this cell having EMF E. So positive will be connected to positive so that it will be charged. And in this case you see current is in a reverse direction like this. Here just check, current is from positive to negative. Here current is like this, negative to positive, just reverse direction. That's why it is plus. So V is equal to E plus IR in case of charging, V is equal to E minus IR in case of discharging of a cell. Okay, but to find out maximum current, so this is the formula for current. If you are told to find out maximum current, so what you have to do? You have to make R 0. If R is equal to 0, current will be maximum. I mean, this is the case of a cell with internal resistance. So for maximum current, the formula will be I max is equal to E by R. Okay, so students, how to solve problems now from NCERT. Suppose a question is here, suppose question number 1. The storage battery of a car has an EMF of 12 volt. A storage battery has EMF of 12 volt. So first you read the question till understanding you read. Number of times you read to understand the question. So E is equal to 12 volt. If the internal resistance of the battery is 0.4 ohm, internal resistance means R is equal to 0.4 ohm. What is the maximum current that can be drawn from the battery? So to find out maximum current, already you know the formula I max is equal to E by R. So after putting all these values, your answer will be 30 ampere. That means this cell having internal resistance 0.4 ohm gives a maximum current of 30 ampere. Now come to question number 2. A battery of EMF 10 volts and internal resistance 3 ohm is connected to a resistor. If current in the circuit is 0.5 ampere, what is the resistance of the resistor? So what are given in this question? EMF is 10 volts, so this is 10 volts. Internal resistance is 3 ohm. R is the internal resistance, students, 3 ohm. Current is 0.5 ampere. And you have to find out resistance of the resistors means capital R. You are told to find out capital R. So what is the formula? So formula you know, I is equal to E divided by R plus R. So after putting all these values, I, this is E, this is R, you will get capital R is equal to how much? That will be your 17 ohm. In this expression, if you put E, I, R, your capital R will be 17. Also, what is terminal voltage of the battery when the circuit is closed? When the circuit is closed, means current will flow. When you see, this is your internal resistance, this is your external resistance. Suppose this is a switch. So closed means switch is on. When switch is on, current will flow. And in this case, your potential difference or terminal potential difference, terminal voltage, V is equal to E minus IR. E is there, I is there, R is there. After putting this, you will get what? That is your 8.5 volt. You check it. You put this, you will get 8.5 volt. Either in this way you calculate, or another formula V is equal to I into R, because R is already found out. So I is 0.5. So 0.5 into 17, that is 8.5 volt. Either this or that you can follow to find out this terminal voltage. If I move to question number 3. In question number 3, three resistances 1 ohm, 2 ohm, 3 ohm are connected. What is the total resistance? Very easy. This is 1, this is 1, this is 1. Here it is 1, 2, 3. 1 ohm, 2 ohm, 3 ohm are connected in series. What is the total resistance? Means you are told to find out equivalent resistance, and simply you have to add. That is 1 plus 2 plus 3, that gives you 6 ohm. So in first bit of question number 3, you get answer is 6 ohm. Now in second bit, this is the first bit. In second bit, what is told? You are told to find out, that is potential drop across each. Suppose it is connected in this question. This is connected to a voltage of 12 volt with negligible resistance. Means its internal resistance is neglected. It has no internal resistance. So 1 ohm, 2 ohm, 3 ohm. And you are told to find out V1, V2, V3. So what is I? First you have to find out current I, because voltage is equal to current into resistance. Current into resistance. Current into resistance. So what is current? Current is equal to E divided by equivalent resistance R. What is E? 12 volt. What is equivalent resistance? 6. So that will be 2 ampere current. So since this current I is 2 ampere, now V1 will be I into R1. Matlab 2 into 1 is equal to 2 volts. V2 is equal to, like that you have to find out 2 into 2, that is 2 into 2 is equal to 4 volt. Similarly students, V3 is equal to current I into R3. I is 2, R3 is 3, 6 volt. So answer is 2 volt, 4 volt, 6 volt. In this way we can solve numericals.